Students, today we will start our second topic, that is Pythagoras theorem. What is the Pythagoras? Pythagoras is the name of mathematician who is the great Greek mathematician who gives us a Pythagoras theorem, or who invented a Pythagoras theorem. First of all, we will see the Pythagoras theorem. In a right angled triangle, the square of hypotenuse is equal to the sum of the squares of remaining sides. Okay. For this, if we draw a diagram in triangle PQR, angle PQR is equals to 90 degree according to Pythagoras theorem. Square of hypotenuse, which is the hypotenuse here, PR. Its square means PR square is equal to sum of the squares of remaining side. Sum means addition of squares, but which sides? Remaining sides, means PQ square plus QR square. Therefore, in right angle triangle PQR, according to Pythagoras theorem, PR square is equals to PQ square plus QR square. Next point is Pythagorean triplet. Triplet means a set of three. Okay, triplet. In a triplet of natural numbers, if the square of the largest number is equal to the sum of the squares of the remaining two numbers, then the triplet is called Pythagorean triplet. For example, we are taken here a triplet 11, 60, 61. Out of these three number, which is the largest one? Here 61 is the largest number. First of all, we are squaring the numbers. 11 square is equals to 121, 60 square 3600, and 61 square 3721. And if we observe, if we add 121 and 3600, which is equals to 3721. 121 is nothing but square of 11. That is 11 square plus 60 square is equals to 61 square. Means a square of largest number is equals to sum of squares of remaining two numbers. Or the both sides are equal, then the given triplet is Pythagorean triplet. Therefore, 11, 60, 61 is the Pythagorean triplet. Next is property of 30, 60, 90 triangle. If acute angle of right angle triangles are 30 degree and 60 degree, then the side opposite to 30 degree is half of hypotenuse, and side opposite to 60 degree is root 3 by 2 times the hypotenuse. 30, 60, 90 triangle means the measures of triangles are 30, 60 and 90 degree. Then what property say? The side opposite to 30 degree is half of hypotenuse, and side opposite to 60 degree is root 3 by 2 times the hypotenuse. For example, in triangle LMN, angle L is equals to 30 degree, angle N is equals to 60 degree, and angle M is equals to 90 degree. Means triangle LMN is 30, 60, 90 triangle. According to this property, here hypotenuse is ln. Side opposite to 30 degree means mn is half of ln. And side opposite to 60 degree means lm is root 3 by 2 times the hypotenuse, means ln. Next, property of 45, 45, 90. Means the acute angles of right angle triangles must be 45 and 45 degree angles. If the acute angles of the right angled triangle are 45 degree and 45 degree, then each of the perpendicular side is 1 by root 2 times the hypotenuse. Means the measures of angles of a triangles are 45, 45 and 90 degree. For example, in triangle XYZ, angle Z and angle Y are equal, that is congruent, which of measure 45 degree, and angle X is equals to 90 degree. Means triangle XYZ is 45, 45, 90 triangle. Therefore, according to 45, 45, 90 property, XY, which is equals to XZ, is equals to 1 by root 2 times the hypotenuse. Means 1 by root 2 times the ZY. Next point is similarity and right angled triangle. We have seen already the similarity of triangle and test for the similarity of triangles. First property is in a right angled triangle, if the altitude is nothing but the perpendicular from vertex on the opposite side. If the altitude is drawn to the hypotenuse, then the two triangles formed are similar to the original triangle and to each other. Okay, if we observe the figure, in triangle ABC, angle B is equals to 90 degree. Segment BD is perpendicular to segment AC. Means segment BD is the altitude drawn to the hypotenuse. Then the two triangles formed, which triangles are formed here? Triangle ADB and triangle BDC. These triangles are similar to original triangles. Means similar to triangle ABC. Okay. Then first see here, triangle ADB is similar to triangle ABC. Second is triangle BDC is similar to triangle ABC. And third property is triangle ADB is similar to triangle BDC. Means in right angle triangle, if we draw an altitude to hypotenuse, then two triangles formed are similar to original triangle and with each other. Next property is theorem of geometric mean. Okay, first of all, what is the meaning of geometric mean? If C is geometric mean of A and B, then C is equals to square root of A into B, which is nothing but the geometric mean of A and B. Now see, in a right angled triangle, the perpendicular segment to the hypotenuse from the opposite vertex is the geometric mean of the segments into which the hypotenuse is divided. Here in triangle PQR, angle Q is equals to 90 degree. Segment QS is perpendicular to segment PR. Okay, then what is here? The hypotenuse, the perpendicular segment to the hypotenuse, means QS is geometric mean of which segment? Segment RS and segment PS. Therefore, by theorem of geometric mean, QS square is equals to PS into RS. Or if we take square root on both sides, what we get here? QS is equals to square root of PS into SR. This is nothing but a theorem of geometric mean. Next part is converse of Pythagoras theorem. In a triangle, if a square of one side is equal to the sum of squares of remaining two sides, then the triangle is a right angled triangle. In triangle PQR, if PR square is equals to PQ square plus QR square, then triangle PQR is a right angled triangle. This is the converse of Pythagoras. Take in mind, if the triangle is right angled triangle, then PR square is equals to PQ square plus QR square, and its converse is if PR square is equals to PQ square plus QR square, then triangle PQR is a right angled triangle. Now we will discuss the examples which are based on these properties. First example is identify with reason which of the following are Pythagorean triplets. First is 3, 5, 4. First we square all the numbers. 3 square is equals to 9, 5 square is equals to 25, 4 square is equals to 16. Now if we observe, 9 plus 16 is equals to 25. That is 3 square plus 4 square is equals to 5 square. Square of largest number is equal to sum of squares of remaining two numbers. Therefore 3, 5, 4 is Pythagorean triplet. Now we discuss second example, 4, 9, 12. 4 square is equals to 16, 9 square 81, 12 square 144. Here 16 plus 81, which is equals to 97, which is not equals to 144. That is 4 square plus 9 square is not equals to 12 square. Means square of largest number is not equals to sum of squares of remaining two numbers. Therefore 4, 9, 12 is not a Pythagorean triplet. Next, in figure, angle MNP is equals to 90 degree, segment NQ perpendicular to segment MP. MQ is equals to 9, QP is equals to 4, find NQ. In right angle triangle MNP, segment NQ is perpendicular to segment MP. Therefore, we can use the theorem of geometric mean. According to this, NQ is equals to square root of MQ into QP. Reason is theorem of geometric mean. If we substitute the values, square root of 9 into 4, which is equals to square root of 36, which is equals to 6. Here we use the theorem of geometric mean. Now next example is, see figure, find RP and PS using the information given in triangle PSR. In triangle PSR, angle S is equals to 90 degree, angle P is equals to 30 degree. Therefore, by angle sum property, angle R is equals to 60 degree. What is the angle sum property? The sum of measures of angles of triangles are 180. Therefore, 90 plus 30 plus 60 is equals to 180. According to angle sum property, angle R is equals to 60 degree. Therefore, triangle PSR is 30, 60, 90 degree triangle. Therefore, according to 30, 60, 90 property, SR is equals to SR. If we observe the figure, SR is a side opposite to 30 degree. SR is equals to half of PR. SR is equals to 6, which is equals to half into PR. Therefore, PR is equals to 6 to the 12. Now, PS is equals to root 3 by 2 times the PR. PS is the side opposite to 60 degree. Therefore, it is root 3 by 2 times the hypotenuse. Root 3 by 2 times hypotenuse length 12, which is equals to 6 root 3. Here we use the 60, 30, 60, 90 property. Now, next example is find the side and perimeter of a square whose diagonal is 10 centimeter. First, we have to draw diagram. Here, quadrilateral ABCD is a square. BD is the diagonal. We know that all sides of squares are congruent. Therefore, AB is equals to BC is equals to CD is equals to AD, sides of a square. Let AB is equals to AD is equals to X. Now, in a right angle triangle DAB, we are going to apply a Pythagoras theorem. Okay. Therefore, by Pythagoras theorem, BD square is equals to AB square plus AD square. 10 square is equals to X square plus X square, which is equals to 2X square. If we divide by 2, therefore 50 is equals to X square. Taking square root on both sides, square root of 50 is equals to X. If we split the 50 into 25 and 2, taking square root, 5 square root of 2 is equals to X. Side is equals to 5 root 2 centimeter. Similarly, we have to calculate the perimeter. Perimeter is equals to 4 into side. 4 into 5 root 2, which is equals to 20 root 2 centimeter. Next, in triangle LMN, L is equals to 5, M is equals to 13, N is equals to 12. State whether triangle LMN is a right angled triangle. Here the lengths are given. First we do the squares. L square is equals to 25, M square is equals to 169, N square is equals to 144. But if we add 25 to 144, which is equals to 169, that is L square plus N square is equals to M square. Therefore, by converse of Pythagoras theorem, triangle LMN is a right angled triangle.